Hey everyone, we are starting Unit 2, Part B today. The other 8th grade math teachers and myself decided that it would be best to break Unit 2 into two parts. So this is Unit 2, Part B that we're starting today, and this is all about scientific notation. We're going to talk about how can I express very large and small numbers in scientific notation, and we're going to answer how many numbers can be in front of the decimal place in scientific notation. So real quick, what everyone's going to do is just to review our exponents. Try these three questions real quick. Pause the video. I want you guys to try these three questions and see if you can get them right. Okay, so hopefully you paused and you've tried to do these. So we're going to start with this first one, number 1. This is product of powers in the numerator and quotient of powers with the denominator. So we know product of powers is we keep the base and we add the exponent. So we're going to keep the 8s, and we're going to do 6 plus -2 is 4. And then down here we have 8 squared. So I have 8 to the 4th divided by 8 squared. And this is division. So we keep the base and we subtract the exponent. So we get 8 squared. And we actually know 8 squared. So we're going to simplify that to 64. Okay. All right, number 2, there's no product of powers or quotient of powers. There's just this pesky negative exponent we have to deal with. So what we're going to do is we're going to make a fraction. If it's the coefficient gets to stay on top, the positive exponent gets to stay on top, and the variable with the negative exponent is going to move down to the denominator, so it's 3x to the 5th divided by y to the 9th. And then this is the power of a power, and one of the things we need to remember here is that even the 4 has an exponent of 1, so we're multiplying all of these exponents by 2, which is the power of the power. So I have 4 squared times a to the 4th times b to the 6th power. Then, the only other thing I'm going to do is I know that 4 squared is 64. So I have 64, a to the, no, I'm sorry, my bad, my mistake, not 64. 4 to the 2nd is 16. So I have 16, a to the 4th, b to the 6th power. Okay, so just a little warm up to jog your memory. We are going to go over this, and you need to watch this video before you come to class today. I'm going to have to bounce back and forth between a couple different things through your guided notes and through the whiteboard. So I am attaching some guided notes to this assignment. You can always print those and complete them. And we're going to actually be focusing on those guided notes as we progress. So I'm going to switch to the guided notes so you can see that. This is what they look like. Everyone see their guided notes? And what we're going to do is we're going to fill these in together. And we're going to start with some vocab. You guys know I love vocabulary. It says, what is scientific notation? So what is scientific notation? Well, our definition for this is that it is when a number is written as the product of a factor and an integer, another text box, and an integer power of 10. All right, this is a long definition. Integer power of 10. The factor must be greater than or equal to 1 and less than 10. Okay, so what does that mean in like just a summary? Is that basically it's saying it is a way to make really small and really big numbers easier to write. We're going to make really small and really big numbers easier to write. Okay, everybody? So, the way we actually see this written in math, like the actual formula for this is that, and I'm going to write this on here, is that we have this, we always have A, which is our factor. So A, why is my pen so skinny? Hold on. A, and then it's always going to have the times, and when you're putting work into the OMS, you you need to be really careful because if you don't use their little fancy x, they count it wrong. Times 10 to the nth power. Okay, and the rule here though is that a has to be greater than or equal to 1. So it could be like 1, 1.2, 1.3, 1.4, but it also has to be less than 10. So basically what this means is that we have to have a number that is between 1, 2, 3, 4, 5, 6, 7, 8, or 9, or some decimal form of those, okay? So let's talk about our rules. What are our rules for scientific notation? So the first rule we have is when if a number is blank, the power of 10 is blank. So if a number is what, the power of 10 is what? What do you guys think that's going to be there? Anyone figure it out? If the number is greater than or equal to 1, then the power of 10 is positive. Okay? If the exponent is a positive exponent, the exponent is positive, we move to the right. We're going to move to the right. So if it's greater than or equal to 1, the power of 10 is positive. So basically meaning if it's a really big number, the power of 10 is positive. Okay? I'll write this down. All right? Then, and I used to make my kids do the Cupid shuffle with this because we go to the left, to the left, to the right, to the right. So we always do that, okay? So then what happens if the other scenario is that if the number is between 0 and 1, the number is between 0 and 1. So basically, if the number is a decimal, then the power of 10 is negative, is a negative power of 10. I know this is a lot of wordiness right now, but I promise it's gonna make sense. So if the exponent is negative, move to the left. Okay, so make sure you have these notes copied in, and I'm gonna pause this real quick, and I'm gonna switch to the whiteboard because I really wanna make sure you guys can follow what I'm doing here, and I think it helps to see it on the whiteboard when we actually moving the decimal places, okay? So I'll pause this and switch cameras. You guys make sure you have this written. Okay, so now that I'm set up on the whiteboard, we're going to do the first examples on the guided notes. So your first examples on the guided notes are talking about converting from scientific notation to standard form. So standard form is what we call it when we just write numbers like the normal way that we're used to. Scientific notation is this fancy new way we're learning. So we're going to do our first example. Our first example is when we have a positive n. So positive n, so positive exponent basically, means that we move right. Okay? So number one, I have 5 and 34/100 times 10 to the 4th power. Okay? So notice here that we have a decimal place. We have one number in front of the decimal place. And we have n, our exponent is positive. So this means we are going to move 4 right. So what are we going to move 4 right? Well, we're going to move that decimal place. So what I'm going to do is I'm going to write 5 and 34/100 down here. I'll say, okay, here's a decimal. I'm going to move it 1, 2, 3, 4 times. So now my decimal is back here. What goes in these empty spots? If you said 0, you're exactly right. We put zeros in these empty spots. So I get 53,400. And now the decimal's back here. We can write it if we want to, but it's also understood. Okay, so we get 53,400. So this was just a shorter way to write this big number. All right, the next type we have is if we have a negative n, that means we're going to move left. We're going to move left. So number 2, I have 3 and 27 hundredths times 10 to the negative third. So we have a negative exponent and some negative 3. So it means we're going to go 3 left. This number is going to get smaller. So I have 3 and 27 hundredths. I move my decimal 1, 2, 3 times. And in these empty spots, I'm going to put zeros. And since this time the decimals in the front, we do have to write it. It's not understood. So what this converts to is 0.00327, which is tens, hundredths, thousands, 10,000s, 100,000s. So 327 hundred thousandths. Okay? So this is how we go from scientific notation to standard form. So if you're going in the guided notes, you can go ahead and write this down. Okay? All right, so let's do some practice. I'm going to put 3 problems on the board, and I want you guys to try and answer these 3 problems, okay? So you're going to do example A is 7 and 42 hundredths times 10 to the 5th. Example B is 6 and 1/10 times 10 to the negative 2nd. And example C is 3 and 174 hundredths or thousandths times 10 to the 2nd. So I want everyone to take a second, answer these. I'm going to pause the camera. You guys need to pause yours, write these out, and then we'll go over. Okay, so hopefully you actually paused it for more than just a couple seconds, but we're going to work these out together, and I'm going to grab another marker. All right. So A is 7 and 42 hundredths to the 5th times 10 to the 5th. This means we are moving 5 right. So I rewrite the decimal. I know a lot of you want to skip this step, but it really does help you guys to visualize. If you write the decimal without the times 10, and then I count, okay, 1, 2, 3, 4, 5 to the right. I have 3 empty circles, so I put in 0, or 3 empty slots, so I put in zeros, and I have 742,000 is my answer in standard form. Okay. Now, make sure that you remember the decimal is now back here, but we know with like numbers that are greater than 1 that aren't decimals, we don't have to write the decimal if it's an even whole number. Okay. So B, we have 10 to the negative 2nd. So 6 and 1/10 times 10 to the negative 2nd. So I'm going to go backwards once and then twice. And I'm going to put a 0 in there, and I went 2 left because it was a negative 2. So this simplifies to 61 thousandths, and I have to write the decimal in 0 on this one. Also, some of you might write it as 0.061. These mean the same thing. I just leave off the 0. So either way is fine. And then C, you had 3.174 times 10 to the 2nd. This is a positive 2, so we're going to go 2 right. So I have 3.174. I'm going to move my decimal once and twice. So my decimal is now here. So this is going to simplify to 317 and 4/10. Okay? Everyone see how I did that? Questions on that? Okay, well, no one's here to ask questions. If you have questions, send me an email or come to class with questions. So I'm going to pause this, and I'm going to flip back to our guided notes for a second to put in some more fill in the blanks, and then I'm going to flip back to the whiteboard. All right, so there's a lot going on here. Okay, so now we've gone through example 1, we've gone through example 2, practice A, B, and C. So now we're going to talk about how do we move from standard form to scientific notation. So how do I go from standard form to scientific notation? What do I need to do here? All right, so I'm going to switch tablets now. Takes me a second. All right, so what is that? So we are going from form to scientific notation. We are going to move the decimal place. We're going to move the decimal place so there's only one number in front of it. So only one number in front of the decimal place. All right, then write the exponent equal to the number of places you moved. So to the number of places you moved. Okay? Everybody got that? I'm giving her a second to write that down, and then I'm going to switch back to the whiteboard. Drop my tablet. It's okay. All right, I'm going to switch back to the whiteboard. I hope everyone has got this. If you don't have it, you can always pause this for a second and write this. Okay, so now we're going to practice going from standard to scientific notation. So I'm going to switch my camera again. And we're going to go from standard form to scientific notation. And this comes in handy if you're ever planning a career in the medical field. You're going to use this a lot, okay? You're going to use this a whole lot. And so it's important to make sure that you understand this concept. So we're going to do example 3. Example 3, you have 3,725,000, okay? So what we want to do is we want this to be in scientific notation. So that means we can only have one number in front of the decimal, and it has to be a number greater than 1, greater than or equal to 1, but less than 10. So first thing you're saying is like, well, wait a minute, I don't even see a decimal here. You actually know that it's understood. The decimal is understood to be back here behind the 0. So what I'm going to do is I'm going to move my decimal here. I'm going to move my decimal, and I want one number in front of the 0. So that means I'm going to have to move it to right here behind the 3. So let's count how many times I moved that. 1, 2, 3, 4, 5, 6. I moved that decimal 6 times, okay? So now here's how we're going to rewrite this. So we're going to rewrite the 3.725, where my new decimal is. Now, the point of doing this was to make it smaller. So now I get to leave off all these zeros. So 3.725 times 10 to the what power? Well, I moved the decimal 1, 2, 3, 4, 5, 6 times. So that means it's 10 to the 6th power. Okay? I always like the count from Sesame Street. I do this 1, 2, 3. Okay, number 4. I have 0.000316, and I want to write this in scientific notation. And so right now this is a decimal. Right now we have a lot of zeros in front of the decimal and behind the decimal. And what we need in front of the decimal is a number that's greater than 1 or equal to 1. So basically we want the decimal to come right back here. So we're going to go backwards 1, 2, 3, 4 times. So I do that. I have 3.16 times 10 to the what power? Well, if I went backwards 4 times, this is going to be to the negative 4th power. So now we wrote this really, really small decimal as 3.16, which is a little bit bigger number to work with. And then the last example I have is example 5. And example 5 is our favorite kind of problem because it's 8.72 e to the negative 5th. So why did I even, or e negative 5, why did I even put this on here? This is what the calculator gives you. If you ever get a really, really, really big number in the calculator or a really, really small number, a lot of times the calculator will give it to you in scientific notation. All this e means is make this 10 to whatever power. So what this would be is 8.72 times 10 to the negative 5th power. Okay, so that is all we have to do with these. We just take the e and replace it with times 10 and raise it to the exponent. All right, so just the big things to remember here is that if we make the number smaller, it's a positive exponent. If we make the exponents bigger, it's a negative exponent. Okay? So we go from a decimal to a mixed number. it's negative. If we go from a really, really large whole number to a decimal, it's positive. Okay? So I've got 3 for you guys to try. So 3 for you guys to practice. So this is examples D, E, and F. So D is 14,140,000. E is 0.00876. And F is 8.72, e to the positive 5 power. Okay, so I'm gonna pause this, give everyone a second to try these, and then we'll check. All right, so I hope you guys paused this and tried it and waited more than a second to just restart it. So we want to put these in scientific notation. So this first one, our decimals in the very back. We want to move it to right here before this first one. So we're going to move it 1, 2, 3, 4, 5, 6, 7 times. So I have 1.414 times 10 to the 7th power. 1.414 times 10 to the 7th power. Okay? So that is this number written in scientific notation. This number, what we're going to do is we're going to move the decimal behind the 8. So I'm going backwards 1, 2, 3 times. So I have 8.76 times 10 to the what? I went back 1, 2, 3, so the negative 3rd power. And the last one's the easiest one. It's just going to be 8.72, and this time times 10 to the positive 5th power. Okay, so this is how we go from scientific or standard form to scientific notation. All right, real quick, I'm going to flip back to our guided notes. I'm going to flip back to our guided notes because we just have a few comparison problems on the back I want us to look at together. And they're all the way on the very back here, and they're just comparing. So we'll do 2 of these comparing problems, and then I'll leave some for you guys to practice. All right, so number 6 says refer to the table at the right. Order the countries according to the amount of money visitors spent in the United States from greatest to least. So you guys know I'm a big travel person, and I love this particular graph has to do with people who are traveling to our country to see things in our country. So it's people who traveled from Canada, people who traveled from India, and people who traveled from Mexico, okay? And what we're gonna do is we wanna compare these, and we wanna see who spent the most money in our country and who spent the least. So we have a couple of different ways to attack this. Notice that they all have different exponents. We have to the 7th power, to the 6th, to the 6th, and to the 7th. So we can't just look at the decimal parts. What we're gonna have to do is we're gonna have to write these out. So we're gonna start with Canada, okay? Canada is 1.03 times 10 to the 7th. So 10 to the 7th means we're gonna move 7 to the right. So I'm gonna move 1, 2, 3, 4, 5, 6, 7. So I'm gonna put in 1, 2, 3, 4, 5 zeros here because these 2 took care of the first little divots. And so the decimals back here. So people that visit from Canada, we're gonna write this out. So let's see, 1, 2, 3, 4, 5. Spend $10,300,000 if they're from Canada. All right, let's see how much do people from India spend. How much do people from India spend? Well, India is 1.83 times 10 to the 6th. So that means I'm going 10 to the 6th, means I'm going 6 to the right. So 1, 2, 3, 4, 5, 6. I'll put the decimal back here. I'm going to fill in these spots. So now we say, okay, I've got this lovely large number. So that is $1,830,000 spent from people in India. All right, people from Mexico, people who visit from Mexico are 7.15 times 10 to the 6th. That means I'm going 6 to the right. So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to put zeros in for my little empty spots. So I do this, I get $7,150,000 are spent by people in Mexico. And then last but not least, we have people from the UK. which is like England and Scotland and Ireland. And we get 1.06 times 10 to the 7th. So this one, I'm going backwards. 1, 2, 3, 4, 5, 6, 7. So I put in 1, 2, 3, 4, 5 zeros. And so people from the UK spend, let's see, 1, 2, 3, 4, 5 zeros. Spend about $10,600,000 in the US. So this is our greatest. So this is number 1. Okay. And then our next greatest is visitors from China. So this is number 2. Our next biggest is visitors from Mexico. Is number 3. And then last is number 4, India. So this is the least. Okay, so we're just ordering these from least to greatest. If you don't want to write them out, I think it's always good practice to write them out. You're welcome to sit here and compare the factors and the exponents. Say, okay, these two are going to have an extra 0 because they're to the 7th power. So they're obviously going to be bigger than the other two. Okay, and this is why we use scientific notation. It's hard to write all these zeros. It's hard to make sure you're writing them all correctly. So that's what we use this to compare numbers. All right, I'm going to let you do number 6 by yourself. Number 7, 7's super duper easy. If you could walk at a rate of 2 meters per second, it would take you 1.92 times 10 to the 8th seconds to walk to the moon. Is it more appropriate to report this time as 1.92 times 8 to the 10th seconds or 6.09 years? Which one do you guys think would be a better option here? And your reasoning is what matters here. Like, what do you think? What do you think would be your reasoning? Well, if you made it to the end of this video, and I want you to think about this, and just to let me know you watched it when you come to class on our next class session, whichever that might be, A day or B day, I want you to tell me your reasoning. What do you think would be better? 1 and 9200ths times 10 to the 8th seconds, or 6 and 9.09 years? Okay, so come up with an answer for that for our next class. Try number 6 on your own and number 8 on your own. If you have any questions, shoot me an email, and we are going to end there. Have a great day, everybody.